Venn diagram of two sets. A Venn diagram with two intersecting sets breaks the universal set up into four distinct regions. Now we can label these with intersections and complements, but ultimately these regions are the region, if I label this Venn diagram as the universal set U, and it contains the sets A and B that are overlapping, I have the region that only contains A, the region that only contains B, the region that contains A and B, and the region that doesn't contain A or B. So those are labeled, respectively, as A intersect B complement, as B intersect A complement, as A intersect B, and as A union B, in parentheses, complement. We can read what those are with ands, ors, and nots out loud, those statements, and it describes exactly what is found in there, whether it's A and not B, whether it's B and not A and B, or not, or neither A or B. Now, there are four regions here, and so if we have more sets in our Venn diagram, we get more regions. So let's go ahead and look at a Venn diagram of three sets. A Venn diagram with three intersecting sets breaks up the universal set into 8 distinct regions. So these include the regions that, well, first, it's the universal set U with sets A, B, and C, and these are drawn in such a way that there's a region where only A and B overlap, a region where only B and C overlap, a place where only A and C overlap, and a place where all three of them overlap. And those regions where we have only A, only B, only C, or possibly only A and B but not C, only A and C but not B, or only B and C but not A, are labeled with complements, unions, and intersections. So I'm going to say each one of these. So we have the region that only contains A, which is A intersect the complement of B union C. That includes A but not B or C. Then we have the region only containing B, which is B intersected with the complement of A union C, because it only contains B and not A or C. Then we have the region that only contains C, which is C intersected with, parentheses, A union B, close parentheses, complement, which only contains C and does not contain A or B. We can describe the regions where only 2 sets are included as well, because each of those only had 1 set included, but these have 2. So we have the region that's A intersect B intersect C complement, which includes A and B but not C. Or we have the set A intersect B complement intersect C, which includes A and C but not B. We have the region A complement intersect B intersect C, which contains B and C but not A. And then we have the intersection of all three, where all 3 sets are included. A intersect B intersect C. This is the center of our diagram. And then finally, we have the region that does not contain any of these. And it is, parentheses, A union B union C, close parentheses, complement. This is the region that does not contain A or B or C.